So in this video, we are going to discuss how to calculate the area of an annulus. And an annulus is, I guess, just a fancy word for donut-shaped. You are going to be studying hydraulics in the lab and working with pistons. And in order to do that, you need to understand not just how a piston works and the hydraulics, but also how to calculate the area of a donut-shaped piston, if you will. So we're going to take a look at just a simple annulus diagram and see if we can calculate the area. In this case, we're going to calculate the area of just the area of the shaded region, that green that you see there, okay? Now, in order to do that, we really have two circles here. We have that larger circle, and then we have the smaller inner circle, okay? And so the way we're going to do this is, first of all, let's talk about how you find the area of a circle, since that's what we're dealing with here. So the area of a circle, hopefully you all remember this, is just pi times the radius squared. So it's just pi r squared. Now, again, we have two circles here. We have a large circle and we have a smaller circle. And so what we're going to do is we're going to find the area of the larger circle. So I'm going to call that pi capital R squared. And just to be clear on that, that is going to be this entire, when we calculate that area, it's going to be that entire big circle, all right? And I am going to let capital R, I'm just going to pick a number randomly, and I'm going to change colors. So I'm going to let capital R equal, we'll keep the number simple, 4, okay? So if I wanted to find the area of just that larger circle, I would just do A equals pi times 4 squared. And you all know that 4 squared is 16. And so our answer here, we could just say is 16 pi. For the moment, I'm not going to do the multiplication. I will when we get to the end, but I'm just going to leave it as 16 pi, okay? Now, what do I do with that? Because that doesn't give me the area that I'm after. To get the area that I'm after, I'm going to erase for a moment. So I found that bigger area, and now I need to find just the green, but my issue is I've got this opening right here, right? And I've got to get rid of that because that is obviously not part of the shaded area that I'm after. So what I'm going to do is I'm going to calculate that area using the same formula. So I'm going to say area equals, but now just to be clear that it's the smaller circle, I'm going to use a lowercase r. So that area is going to be pi times little r squared, and I'm going to let it little r just be 2. So I have pi times 2 squared, and of course 2 squared is just 4, so I'm just going to have 4 pi here. And now, if I want to find the area that I'm really interested in, which is that green shaded area, all I have to do is subtract. So I am going to take the area of the large circle, which is 16 pi. So the area of my shaded, I'll put a little s there, the area of the shaded is going to be 16 pi minus 4 pi. And of course, that's just 12 pi. And for the moment, I'm going to leave it at that. Now, of course, there is a little shortcut you can take, and I'm going to show you that. There's actually a simpler version of this formula, and what you do is, I'm going to show you where it comes from because I think you should understand that. So basically what we did was we took the area of the large circle and subtracted from it the area of the small circle. So I could write that formula out. I could say that I found the area of the shaded region S by taking pi capital R squared and subtracting from that pi little r squared. And then I have a common factor of pi there, so I can say that the area of the shaded region is pi times capital R squared minus little r squared. And so if we wanted to just check that, we could go back to our original numbers that we used, and we could say, okay, pi times capital R squared was 16, little r squared was 4, so you get 12 pi as your answer. So let's go ahead and put that, 12 pi. okay? And then, of course, you could go ahead and just calculate what that is as a decimal. So if we just do 12 times 3.14, you'll get 37.68. So we'll leave this as 37.68. Now do recall that you should pay attention to units. I'm going to assume we're in inches here, and so I'm going to say that this is inches squared because it would be an area. So this is an example of how you find the area of an annulus, so hopefully you'll be able to do the homework assignment. Have a good weekend.